In this video, we will graph a transformation of the sine function when the equation is in the form y equals a times sine of the quantity bx plus c plus d. The absolute value of a is equal to the amplitude, and if a is less than 0 or negative, the graph is reflected across the midline. 2 pi divided by b is equal to the period, and when graphing by hand, we always divide the period into 4 equal subintervals to make it easier to make an accurate graph. Negative c divided by b is equal to the phase shift or horizontal shift, where if this value is positive, the shift is right. If this value is negative, the shift is left. And then finally, d is equal to the vertical shift. If d is positive, the shift is up. If d is negative, the shift is down. Let's look at an example. Let's graph the function y equals 2 times sine of the quantity negative pi x plus 2 pi plus 1/2. For this function, the first thing we have to recognize is that b is negative. Here, b is negative pi, and 2 pi divided by b is equal to the period. We know the period must be positive, and therefore, we are going to have to change the form of this function here. Let's first factor out a negative from the quantity negative pi x plus 2 pi. This would give us y equals 2 times sine, and now we'll factor out a negative, so we have negative, or the opposite of the quantity pi x minus 2 pi, and then we still have plus 1/2. From here, we are going to use the negative angle identity. Sine negative x equals negative sine x. So notice here the angle is negative, or the opposite of pi x minus 2 pi, and therefore this function is equal to y equals negative 2 sine of the quantity pi x minus 2 pi plus 1/2. So now that we've transformed the equation into a form where b is positive, let's now find the values of a, b, c, and d and describe the transformation. Notice a is equal to negative 2, b is equal to pi, c is equal to negative pi over 2, and d is equal to positive 1/2. Because a is equal to negative 2, the amplitude is equal to the absolute value of negative 2, which is positive 2. So we know the amplitude is equal to positive 2. Because a is negative, though, the graph is reflected across the midline. So let's list that as well. We have a reflection across the midline. Next, b is equal to pi, and 2 pi divided by b is equal to the period. So 2 pi divided by b is equal to 2 pi divided by pi, which simplifies to 2. So the period is equal to 2 units. Negative c divided by b is equal to the phase shift. And notice that c is negative pi over 2. So negative c divided by b is equal to negative, or the opposite of negative 2 pi divided by b, and again b is equal to pi, and therefore this simplifies to 2. Because this value is positive, we have a horizontal shift or phase shift of right 2 units. And then finally d is equal to positive 1/2. So because d is equal to positive 1/2, we have a vertical shift of up 1/2 of a unit. And now let's set up our graph to sketch the function. Well, because we have a vertical shift of up 1/2 of a unit, the midline is not going to be the x-axis or y equals 0. It will be y equals 1/2, which is this horizontal line here. So this is the midline. Next, because the phase shift is right 2 units, we will begin our graph here at x equals 2. And from here, because the period is also 2 units, we will go right 2 more units. 2 plus 2 is equal to 4. We will have one complete graph of our sine function over this period, which is again 2 units. And when graphing by hand, we always want to divide this period into 4 equal subintervals. So we'll divide this in half, and then in half again. So over this interval here, we'll graph one complete graph of our sine function. Because the amplitude is positive 2 and this is the midline, the maximum function value is going to be 0.5 plus 2 or 2.5, which is here on the y-axis, and then 1/2 minus 2 is negative 1.5, which is here. This will be the minimum function value. And now we'll use our knowledge of the basic sine function shown here to graph the given sine function, keeping in mind we do have a reflection across the midline. Looking at the basic sine function shown here over one period from 0 to 2 pi radians, if we divide this into 4 subintervals, we have 5 key points. We start at the midline here, and then we go up to a maximum, back to the midline, down to a minimum, and back up to the midline. We will follow this same pattern for our graph, except we do have a reflection across the midline, and therefore our pattern is going to be midline minimum, midline maximum, midline. Starting at x equals 2, we are at the midline, and then because we have a reflection across the midline, we now go down to a minimum function value here of negative 1.5, back to the midline, back up to the maximum function value of 2.5, and then back down to the midline. And now we can graph one period of the given sine function, which looks like this. And once we have one period, we can simply copy and paste this graph to the left and right, or follow the pattern from left to right. Continuing to graph on the right, we would be down at a minimum function value here when x is 4.5. So the graph continues to the right looking like this. And now graphing to the left of x equals 2, let's go ahead and divide the interval from 0 to 2 into 4 equal subintervals to make it easier to graph an accurate graph. So again, following the pattern, starting at 2 and moving to the left, at x equals 1.5, we'd be at a maximum function value, then back down to the midline, back down to a minimum, and then back to the midline. We can now make a nice graph of the given function all the way from x equals 0 to x equals 4.5. The final graph would look like this. I hope you found this helpful.